Hello, this video will address the errors that can be made when performing hypothesis tests. In an experiment, the null hypothesis is the statement that the variable being studied produces no effect or makes no difference. Typically, we create a null hypothesis with the hopes of rejecting it. We run experiments hoping that the variable under scrutiny does, in fact, make a difference. But there are mistakes we can make along the way. There are two types of these errors or mistakes, and they are known as type 1 and type 2. Creative, I know. A type 1 error occurs when the null hypothesis is true, but we mistakenly reject it. It usually leads us to conclude that an effect or relationship exists where there actually isn't one. Let's go over some examples of type 1 errors to understand the concept. A patient comes into a hospital complaining of chest pain. The null hypothesis would be that nothing is wrong. Tests are completed and the doctors conclude that the patient has heart disease. But wait, the patient really just had a heartburn and any treatment would actually harm him. The doctors have made a type 1 error. Or say an unexpected fire alarm goes off at school. Your null hypothesis would be that there's a fire in the building and you should probably run. A type 1 error would occur if there actually wasn't a fire and someone pulled the alarm. The rate of a type 1 error is called the size of the test and denoted by alpha. Alpha typically equals the significance level of the test. Put simply, alpha is the probability of a type 1 error. A type 2 error occurs when the null hypothesis is false, but we fail to reject it. Type 2 is when an actual hit is disregarded by the test and seen as a miss. For example, a patient undergoes an MRI for cancer screening. The test malfunctions and fails to detect any tumors, but the patient actually has cancer. Or an earthquake occurs, but seismologists don't see the tremors on the radar and fail to alert the public. In the medical world, a type 2 error could be a clinical trial of a treatment failing to show that a treatment actually worked, like a missed opportunity. The rate of a type 2 error is represented by the Greek letter beta and relates to the power of the test, which we'll cover in a moment. To remember the errors and how they occur, we have a little table to guide our decisions. A type 1 error could be thought of as convicting an innocent person, and a type 2 error would mean letting a guilty person go free. Or, in the next example, it is pretty obvious to differentiate between a false positive and a false negative. So what is the power, you might ask? The power is every statistician's dream. It is our ability to detect a false positive. The power is the probability of correctly accepting the alternative hypothesis or the ability of a test to show an effect where one truly exists. The power or sensitivity of the test is equal to 1 minus beta, or 1 minus the probability of a type 2 error. All hypothesis tests have a probability of making type 1 and type 2 errors, such as a blood test for a disease. The test will falsely detect the disease in some proportion of people who don't have it, and fail to detect the disease in some amount of people who do have it. Both types of errors pose real-world consequences. A type 1 error in quality control at a car factory could end with the discard of a perfectly fine car, while a type 2 error, or false negative, would stamp a broken car as operational. In some situations, one type of error poses a more serious threat than the other. Minimizing errors isn't a simple fix. For any given sample size, reducing one type of error generally increases the other type. The only sure way to minimize both types of error is to increase the sample size. So that's about it. Try to remember the shape of the table and that the power is what we're hoping to achieve. Thank you and good luck in the rest of AP Statistics.